pyrometric product, as it relates to the ceramic community, is a time temperature measuring device typically used to control and or monitor the firing process. And these can be things such as pyrometric cones, or in the hobby industry, shut-off bars. It can be shrinkage devices such as temp check. Producers of ceramic products use pyrometric devices when they're firing their product. They fire to develop desired properties in the product, such as absorption, strength, color, density, etc. What they're after is consistency and reproducibility within the product. As a result, then, pyrometric products are used so that they can control these fired properties. Anyone firing above 1,000 degrees Fahrenheit can find an application for the use of a pyrometric product. In the glass industry, those people who anneal can find the use of a pyrometric product. In ceramics, structural clay, people manufacturing bricks, or the whiteware industry manufactures of spark plugs, wall tile, floor tile, bathroom fixtures, advanced ceramics, commercials such as potters or hobbyists. In the metal, the heat treating, any of these people can find the need and the necessity for the use of a pyrometric product. Heat work is the relationship between time and temperature. In the ceramic industry, we know that we need both time and temperature to mature a product. We're talking about high temperatures in excess of 1,000 degrees Fahrenheit. Normally we're talking about time anywhere from 20 minutes to as long as 3-4 days. The example that I like to use is that of maturing a turkey. If we have an average sized turkey and we put it in the oven, we have options of both time and temperature to mature the turkey. As an example, we can put it in the oven at 325 and leave it for 4 hours, or we put it in at 275 and leave it in there for, let's say, 5 hours. If we go outside this firing window of time and temperature, we can find that if we put the turkey in for less than the desired maturing, we'll find that the turkey is somewhat under-fired. If, on the other hand, we leave it in for excess of the maturing temperature and time, we'll find that the turkey will come out over-fired. So what we're after then is a certain amount of time and temperature to mature the turkey so that we obtain a high-quality product. We then have what is commonly referred to in maturing this product, a firing window. As heat is applied to the cone, there's various physical and chemical reactions that are taking place. When we near the point where the cone can no longer retain its original shape due to the shrinkage or the melting of the cone, it actually at that point starts to deform. Using pyrometric cones, we start out by having the cone mounted at an 8 angular degree with the vertical. As this melting occurs and the cone loses its ability to retain its original shape, it deforms, typically from the so-called 8 angular degree all the way down to what we refer to as the end point, or a 90 angular degree. The movement then occurs from 8 to 90, or over an 82 angular degree bend. After firing, we should obtain the cone, look at it, for the appearance, the texture, for the amount of bend that actually occurred within a cone. We should take this data and information and then log it into a book so that we can have the assurance of consistency, reproducibility within the firing, and then possibly look at it for potential firing problems that can help us down the road. Cones placed in a kiln basically is determined by the size of the kiln and perhaps what it is that you're trying to find out within the firing of the kiln itself. For normal firings, several locations are typically used. For small kilns, those of 2, 5, 10 cubic feet, cones would be used at the top and perhaps the middle or the bottom, several cones within a firing. In larger kilns, typically used within, let's say, the structural clay industry, where thousands upon thousands of bricks are being fired on a kiln car. The ability then that we have after firing is to make sure that we have a good, consistent, reproducible firing. Or if there is a problem within a firing, these cones then can be used to help us to determine what the problems are and how to solve the problem. Probably 2 or 3 cones would be best, and in some cases 4, depending again on the uniformity of the kiln that we're placing these cones on. If we use 3, we have the ability of a guide cone, a firing cone, and or a guard cone. This then gives us the ability to find differences in uniformity within a fairly large range from top to bottom, or left to right, or front to back.